Good morning, everyone. Today we are going to be talking about finding the slopes of linear equations and finding the slopes by using the slope formula and by graphing them. All right, we are going to get started. Go ahead and pull out a blank sheet of paper from your notebook. We are going to start by writing down a couple definitions, and then we will move into some examples. All right, first I want to define the term linear equation. That's an equation that describes a straight line on a graph, and typically the exponents on the equations of a linear equation, it just has one. It doesn't have any higher power, which you guys haven't necessarily learned what that means yet, but it'll make more sense as we move forward in the semester. Next, I want to talk about independent versus dependent variables. Independent variables are usually our x's, and they are the ones that we get to choose what numbers they are. So their variation doesn't depend on anything else. It just depends on what we pick it to be. So you can often pick a bunch of different values for that, and it will work. Anything that you choose for that will work. Next, I want to talk about dependent variables. Those are often denoted by a y symbol, and those are variables whose value depends on the value of a different variable, meaning when we have an equation, there's usually an input and an output. X is usually our input and y is our output. So we choose something to be we choose a value for x, and when we choose that value, we plug it into our equation and it spits out a number for y. So we don't necessarily get to choose it. It depends on what the x is. Next, I'm going to talk about the slope of a line. It's also referred to as the rate of change when you're dealing with word problems and such. So the slope is a number that describes both the direction and the steepness of a line. I'm going to give you a second to copy these definitions down, and then we're going to talk about the formula for the slope of a line. Okay, now, when we are given two coordinates, x and y, we can plug those coordinates in to determine what the slope of our line is. So, here it is below. I'll give you a second to copy that down. All right, so the formula for the slope, which is denoted by m, is y2 minus y1 all divided by x2 minus x1. And those y2, y1s, those come from right in here where our x1, y1, x2, y2, when the two coordinates are given to us. And you guys will see an example like that later on. I just wanted to spell it out for you very quickly before we moved on. In a different way to find the slope of a line, you can do rise over run. And that is something that you would do if they were just giving you a graph and you had to count the slope of a line. So we're going to do an example like that as well. So the rise would be like the number of boxes you move up and down, top to bottom, from one point to another, and then the run is side to side. So we're going to get to that in just a minute. There are lots of different types of slopes of lines, and we're only going to be talking about the first three today. Those are the only three examples that you'll see. We are not going to get to undefined until our next lesson, so I don't want you guys to worry about that for right now, but I just wanted to include it and show you what it looks like so that it's a little familiar to you when we do the next lesson. All right, so you could have a positive or a negative slope or a zero slope. Those are the three that we're going to be focusing on today. Now, when we try to decide if a slope is positive or negative, we look at it as if we're reading a book, so from left to right. So this first slope here is positive because we are starting low down here, and we are increasing as we read from left to right. It's going higher and higher. Same thing with our negative. From left to right, we're moving down, so that's why it's a negative slope. And then a zero slope move side to side, but there's no vertical change. I'm not increasing or decreasing. I'm just staying at the same height the whole time. And you guys will see a couple examples of that in just a second. We're going to move on, okay? All right, example 1. Find the slope by graphing. So I'm going to work through this with you guys, and I want you to copy down what I write as I go, okay? All right, so it gives us 2 points. It lists them, 1, -1, and 3, -5. And if we remember, this would be one of the times where we use the rise over run formula for slope. So we are going to first plot our points, and I hope this works. Let's see, I might need to move this guy. Yeah, we're going to go over to the corner. Okay. So start by plotting our point. So first point is right over there in pink. It's 1, comma, -1. Our second point, oh man, I don't know why my first point disappeared. Okay, well our second point is 3, -5. So how we handle something like this is we plot our 2 points and then we connect them with a line. There it is. Okay, we're back now. So you plot your 2 points, you connect them in a straight line. Now the next thing we're going to do is we're going to count how many spaces I go up and down, and then how many spaces I go side to side. So if we were to draw a little triangle connecting these 2 points, how many spaces are in each direction? Oh man. Okay, we're just going to start here. So if I start here and I go down to the height of my next point, I would move 1, 1, 2, 3, 4. So our rise is 4. Now, here's the catch. Am I counting upwards or downwards? Good job! I'm sure you all figured out that it's downwards. We're moving down. So instead of listing my rise as a 4, I'm going to list it as a -4. Next, I'm going to count how many units I move from side to side to get from one point to another. So if I start here, which is where I ended up when I was counting, I'm going to move over 1, 2. So my run is a +2 because I'm moving from left to right. Oh, there's my little graphic. All right, and then take a look over here. This is where it came in. We listed a -4 for our rise because instead of rising, we went down in height. And then we listed a +2 for our run. We simplify our fraction and we get a slope of -2. Which if I move back to this picture right here, you can see when I'm reading left to right, my slope is decreasing. I start here, and as I move from left to right, I'm going down. So I have a negative slope. So -2 is correct. That's how we can check our work. All right, now we are going to move into a couple examples of finding the slope using the slope formula. First thing first, remember the formula has all the y1s and y2s in it. So the first thing I'm going to do is go through and I'm going to label each of these points. Oh, I can't get them all to show up at the same time. So I'm going to go through and I'm going to label my x1, my y1, my x2, and then my y2. Then I'm going to take all those points, plug them into my formula, which I listed again for you guys right here. y2 minus y1 over x2 minus x1. So I plug them straight in. My y2 is right here. 3 minus y1 is 15. x2 is 5 minus x1 is 9. If I do that subtraction, I'm going to get a -12 here. And then I'm going to get a -4 on the denominator. So I get -12 over -4. When I simplify that, I have 2 negatives, so that makes a positive. 12 divided by 4 is 3. Now, I didn't graph these equations, but if you ever wanted to check your work, you could. You could go to a graphing calculator, or an online graphing utility such as Desmos, type in your 2 points and check out your line. It should tell you what the slope is there, so you can even do it that way. I mean, obviously you have to show your work on these steps, but that's a way that you can check it. All right, we're going to move on to example B over here. -2, -4, and +2, +2. So we label our x1, y1, x2, y2. Sorry, I don't know why this guy's flashing over here, but you guys get the idea. You can always pause the video and rewind a little bit and figure it out. Okay, so we're going to plug them all into our points. This one's a little bit more confusing, and that's why I included it on here, because look, we've got all these negatives going on. And this is something that people mess up all the time, so I want to make sure that we're really clear on this. We plug in our y2 and our y1, so we're going to do 2 minus, because of the formula, 2 minus a -4. So we have two negatives here, 2 minus -4. I put that negative in parentheses so that you guys are aware that there's 2 subtraction signs there. And same thing in the denominator. x2 is 2 minus x1, which is -2. 2 minus -2. Since I have 2 negatives right next to each other in both my numerator and denominator, they both are going to become plus signs. So my next line, I have 2 plus 4 and 2 plus 2. That gives me 6/4, and I always want my slopes to be in simplest form, so I'm going to put 3/2. Easy peasy. All right, if you have any questions so far up to this point, I want you to pause the video, take note of them, write them down in your notebook as you're taking notes, and I want you to ask them in class when we come in on Monday. We're going to move on. Okay, now we're going to practice. So, the following problem, I want you to work through it individually, because when we come into class on Monday, I want you to pair up with a partner, and we're going to discuss like how we went about this problem, but for the meantime, work on it by yourself. All right, find the slope of the line. Be sure to specify whether it is positive, negative, or a 0 slope. So here are your 2 points. I want you to use the slope formula and get ready, set, go. Go ahead and pause the video right here so that you can keep it up on, keep this screen up, because it's going to change in just a minute. So pause it here. Okay, I'm sure you guys have all worked through this problem. Now we're going to move on. I'm going to post the solution to the problem. I'm going to show you the graph, and then I want you to write down any questions that you might have about this problem, because I'm going to have you partner up when we get back on Monday, and we're going to talk about it and see what you guys did right, what you guys did wrong, and that's the key part. If you got this problem wrong and you didn't get the correct answer, please do not erase it. Don't change it. Wrong answers are okay. I want to see your wrong answers so that we can all talk about it and go over how to fix it, because I guarantee there will be more than one wrong answer. So please don't be embarrassed if you get the wrong answer, okay? All right, we are going to move forward. Here's my solution. I plugged in y2 minus y1, which in this case happens to be 3 minus 3. That gives me 0. So I have 0 in my numerator. When I have 0 in the numerator, it does not matter what I get in the denominator, because my fraction is going to be equivalent to 0. So I did get -7, but the overall value of my fraction is 0. Meaning the line going through these 2 points has a slope of 0. Now, if you got this answer and you weren't sure whether it was right or wrong, here's a way that you could have checked. Here's our graph. I went in and I plotted my 2 points first, 4, 3, and 4, 3 right here, and -3, +3. Then I drew a line through the 2 of them, and as you can see, my height stays the same. My line is not going up or down when I read from left to right, which tells me that I have a height or a slope of 0. So now you know that your slope is correct. You don't even have to worry about it. I can't wait to see how you guys did when we come into class on Monday.